Okay, so in this video we're going to have a look at differentiation from first principles. Now I have explained this in a little bit more depth just in terms of one example in my introduction to differentiation video, but we're going to have a look at a few different questions in this particular one, and we're going to have a look at 5 in total. Now I'm going to start by running through this one, and then I'm going to just allow you to just sort of have a go at the next ones. So I'll ask you to sort of pause the video in between questions and have a go at them. But we're going to run through 5 different questions here on differentiation from first principles. Now this one here says prove from first principles that the derivative of x squared is 2x. Now I'm going to explain this a little bit more in the first part here, but we're going to have a look at obviously just applying the formula to these questions. But hopefully this little first bit will give you an introduction as to why we get the formula and how it works and why we use it. So in terms of x squared, if we imagine part of the curve of x squared, and let's just imagine something like this. Now if we have a look at 2 coordinates on that, so let's pick one here and let's just pick one up there. Now, in other words, when we're finding this derivative, we're looking for an expression that will allow us to calculate the gradient at that specific point. And we know that calculating the gradient, we look between these 2 points here. So if I draw this in, obviously between these two, we could work out the gradient of that line just there. And if we were to do that, we would have a look at these coordinates. And if we imagine this coordinate down here, we would have an x coordinate, and our y coordinate would be determined by whatever the function of x is. And if we have a look at this one here, our function of x for this one is x squared. So if we just write up here that f of x at the moment, our function of x is equal to x squared. Okay, so our y coordinate down there will be determined by that. Now if we just call the y coordinate here the function of x, as obviously our function can change in between questions, that would be our coordinate just there. Now if we imagine as well, obviously when we're working out gradient, we're looking at rise over run or change in y over change in x. So if we imagine that obviously our distance in x moves across here, and then it goes up to our new coordinate there for our change in y. Now if we call our change in x, that we'll just call it the letter h, okay, then our change in y will also be determined by whatever the function is. So for that new coordinate just up there, and let's think about it, the x coordinate is going to be x plus whatever that distance h is. Okay, obviously that's going to change depending on what we're looking at. And our y coordinate there, again, will be determined by whatever the function is. Now in this case it's x squared, but it's going to be whatever the function of x plus h is. So it goes, let's just write x plus h there in terms of our y coordinate. Obviously for this one, x squared, we could actually just write that in terms of x squared, but in terms of thinking about this for any expression or any equation here that we're going to have a look at, or any graph, we'll just think about that in terms of the function of x plus h. Now, looking at this, we know that to work out the gradients, we do the change in y over change in x, okay, so if we write that out, the change in y over the change in x, and we'll write what that is in terms of these pieces here, or these coordinates. Now if I highlight them, for starters, if we have a look at the y coordinate on the top, the change in y, our larger y coordinate is this one up here, f of x plus h, and our smaller y coordinate would be this one down here, f of x. So in terms of working out the change in y, we would take the bigger one, which is the function of x plus h, and we would take away the function of x, and that would be our change in y on our numerator there. In terms of our change in x, our denominator, we would have the larger x coordinate, which in this case is x plus h, and we would take away the smaller coordinate there, which in this case is x. And if we write that to the side, because we can simplify this down, we have x plus h, take away the x. Now obviously looking at that, you can see that the 2 x's there are going to cancel out, so all we'll be left with is the h. So on the bottom there, we are just left with h. Now that right there is the formula that we're going to use for every single question here. We're going to take the function of x plus h, take away the function of x on the top, and we're going to divide it by h on the bottom. And let's just have a look at how we're going to apply that to this one here when we have x squared. Now if we look at x squared, bearing in mind we've already said up here that the function of x is x squared, if we put those pieces in, let's see what we get into that formula. So just before we move on, this is going to be absolutely key. This formula here, we're going to use that in every question, so I'm going to write that down at the start of every question. So that's going to be a key one to make sure that you've got written down there. But let's see how we apply it to this here. Now in terms of our function, obviously we know it's x squared, so for the function of x plus h, that first piece just there, that function is going to be, and we're just looking at substituting functions in here, we're going to have x plus h as our function, so into x squared, that would be x plus h that's going to be squared, and we're going to take away the function of x, which in this case is x squared, so take away x squared. And that's all going to be divided by h. And there we go. Obviously, we just need to simplify this down and see where we get to. Now, if we go about simplifying this down, and let's just get rid of some of this drawing here. Let's get rid of all of this. And actually, there we go. Let's move this to the side. So if we look at this bit here, now if we expand that double bracket and let's just simplify this all down and see what we get. So x plus h squared as a double bracket, which we can always write to the side. And let's just write that over here. So x plus h. And if we expand that out, we get x squared plus xh plus another xh there, so plus 2xh. And then our final multiplication will give us the h squared, so plus h squared. And that, again, that's all going to be on the top. We've got a minus x squared at the end there that we need to not forget about, and h on the bottom. And if we simplify this all down, let's see what we get. So we get x squared minus x squared, so they're going to disappear. So on the top there, all we've got is 2xh plus h squared all over h. There we go, and we're almost done. Now we can divide the top by h, or in other words, we could factorise the top by h to start with. And if we have a look at that, let's just see what we get. If you're happy to just divide the top by h, you can just divide the top now. But if we factorise h out, we get h brackets 2x plus h all over h. There we go. Now essentially we can just cancel that h off the top and the bottom, so we can cancel that off. And what we're left with there is 2x plus h. Now that is our final little expression here that we're going to have, but we just need to think about obviously this final step here in terms of the derivative. Now if we think back to that curve, obviously we had these two coordinates, but what we're actually trying to find is the gradient at one specific point and not between 2 points. So what we're going to imagine is that we pull this point right down on top of that point, pretty much exactly on top of it. But obviously if we do pull it perfectly on top, then there will be no change in y, or there'll be no change in x. So what we do is we use this language or this notation. We say as the limit of h, and we say as it approaches 0. Obviously in terms of this, we can't actually have it being exactly on 0, because then we won't have any change in y or change in x. But we're going to imagine for the sake of this that we're going to have it approaching 0, or essentially we're going to have h as 0. So if we just write h as 0, what we end up with here is 2x plus 0. And as h approaches 0 there, what we're actually left with is just 2x on its own. There we go. And there we go, we've proved that the derivative of x squared is 2x, okay? Obviously from first principles. But this is important here, we just write this little bit of language down. We say as the limit of h approaches 0, okay? And obviously then we just sub 0 in place of h essentially, just to show that that's what the derivative would be at that point. But there we go, that's how we're going to go about this question. Obviously a lot of the explanation that I did there you're not actually going to need in terms of answering the question yourself. You're only going to need this bit that's on the screen right now, and that is obviously starting with the formula just here. Then we sub our function of x in place for that, and that was our step up here. Simplify that all down, divide the top by h, which was on the bottom, and then sub 0 in place of h, and we'll end up with our final piece there. But there we go, there's our first question. Let's have a look at our second one. Okay, so here's our second question. So let's not forget our little formula that we're going to use, which is the function of f of x plus h, take away the function of x, and that's all going to be divided by h. So that's the formula there that you're going to use, okay? In this particular question, our function of x is 5x squared, and we're going to show that it goes down to 10x. So there we go. Obviously, if you're going to have a go, pause the video there and see what you get. But otherwise, let's carry on with this question. Okay, so this time our function of x is a 5x squared. So we've got a little bit more working out when we put this piece in here, because obviously we've got the first piece to work out, which is where we're going to work out the function of x plus h. And if we sub x plus h into 5x squared, we're going to get this. We get 5 lots of x plus h, and that's going to be squared. And then we're going to take away the function of x, which in this case is 5x squared. And again, that's all going to be over h. So there's our pieces subbed into the formula there. Now we just need to simplify it all down and see what we get. So if we expand that double bracket x plus h squared, We've got 5 lots of that, so we'll sort that out in a sec. But if we expand that out, we get the same as before. We get x squared plus 2xh plus h squared. And then we're going to take away 5x squared and again divide it all by h. Now we can go about multiplying everything in this bracket here by 5. So we end up with 5x squared plus 5 lots of 2xh is 10xh. And then 5 lots of h squared will give us 5h squared. And then again we've got minus 5x squared at the end. And again all over h. Okay, so we've got 2 pieces that cancel each other out. They've got the 5x squared and the minus 5x squared. So if we get rid of those, what have we got left? We'll have 10xh plus 5h squared all over h. We can divide the top and bottom by h there. So the h will disappear off the 10xh, so we get 10x. One of the h's is going to disappear off the 5h squared, so 5h. And there we go, there's our final piece. Now again, we're going to say as the limit of h approaches 0, we're going to change that h for a 0, so what we end up with is 10x plus 5 lots of 0, which is just plus 0. And obviously you don't need to write plus 0, so we can just get rid of that. And we just end up with this 10x piece, which is exactly what we're looking for. And there we go, there's our final answer. So let's just highlight that. And there we go, that's how we go about that question. But there we go, there's our second one. Let's have a look at another one. Okay, so here's another one. We've got our function of x this time, which is 2x squared. Let's just highlight that, plus 3. And we're going to show that that equals 4x when we find the derivative. So obviously just make sure you write down your formula. You've got the function of x is 2x squared plus 3. And have a go at getting to this final answer. So pause the video there. Otherwise, stick with me and we'll have a go with it now. So our formula, which we'll write down again, which is the function of x plus h. Take away the function of x all over h, and let's just go about substituting these pieces in. So we'll sub x plus h into the 2x squared, so we get 2 lots of x plus h squared plus 3, and we're going to take away the function of x, which is 2x squared plus 3, and I've put it into brackets there because obviously we're taking away both those pieces, so I don't want to obviously add that 3 at the end there. I've just got to be careful with that, and that's all over h. So if we simplify the top, let's see what we get. We get 2 lots of, and we've got the x squared plus 2xh plus h squared again when we expand that double bracket, and then we've got plus 3 at the end. And then we're going to take away both these pieces, so I'll simplify this now. We're going to take away 2x squared and take away the plus 3. So we've got minus the 2x squared minus the 3, and then that's all over h. And again, let's simplify this down. We've got 2 lots of that bracket on the top there, so if we multiply all of these by 2, and then we'll see what we can do with all of that. We've got 2x squared plus 4xh plus 2h squared. Then on the outside of the bracket there, we've got a plus 3 and a minus 3, so they're going to cancel each other out, but we still have that minus 2x squared there, so minus 2x squared, and that is all over h. Now again, looking at how this simplifies, we've got the 2x squared on the top with a minus 2x squared, so they're going to disappear. So let's just write what we have left. We've got the 4xh, so 4xh plus the 2h squared, and that is all over h. Now again, dividing the top and bottom by h. On the top there we get 4x, that h is going to disappear, and we've got 2h left, with one of those h's going when we divide it all by h there. So there we go, there is our final expression there, and again, as the limit of h approaches 0, that h becomes 0, so we are just left with 4x plus 0, so that's just 4x. And there we go, that's what we were looking for, to get that 4x at the end. So let's just highlight that, there's our final answer, and let's have a look at our next question. Okay, so for this one here, we've got x cubed. So we've got a little bit more working out in this question, but we'll have a look at it now. So the function of x in this case is x cubed, and we're trying to show that it is going to equal 3x squared when we find the derivative of it. So let's just again write down our formula. We have f of x plus h, take away f of x, and it's all over h. So let's just go about substituting x plus h back in again. So in terms of this then, we get x plus h cubed take away the function of x, which is x cubed, all over h. Now that means we've got a triple bracket to do this time. So that x plus h there, let's work this out to the side. We know that x plus h squared, because we've done that on the previous questions, gives us x squared plus 2xh plus h squared, and we just need to multiply that by another x plus h. And there we go, so we've got three brackets this time. So if we expand all that out, we've got x squared times both of those, so that gives us x cubed plus x squared h. We've got 2xh to times by both of those, so we'll times it by the x first. So we get 2x squared h plus 2xh squared. Then we just need to times them both by the h squared, so we get plus 1xh squared, and then plus a h cubed at the end. Right, there we go. So there is our triple bracket expanded there. Let's just see what we can tidy up. Now we've got an x squared h and a 2x squared h that can add together, and we've got a 2xh squared and a 1xh squared that we can add together. So simplifying our numerator down, let's see what we've got. We've got x cubed plus 3x squared h plus 2xh squared plus a h cubed at the end, and then not forgetting on our numerator we've still got this minus x cubed at the end, so add that in as well, minus x cubed, and that's all over h. Looks a little bit more complicated than some of the previous ones, but there we go. Let's have a look. We've got an x cubed here and a minus x cubed, so they're going to cancel each other out, and none of the others simplify there. So if we have a look, we now have 3x squared h plus, and I'm sure that should have been a 3 on the top there. There we go. Let's just get rid of that 2. That should have been a 3. There we go. Let's just double check that. Yep, we had a 2 and a 1 there, so that should have been 3xh squared. There we go. Fix that. And then we've got plus that, so 3xh squared plus the h cubed, and again all over h. Now if we divide the top and bottom by h, let's see what we get. So on the top there, the h is going to disappear with the 3x squared, so we get 3x squared plus, we're going to have 3xh plus h squared. There we go. And then again, as the limit of h approaches 0, if we sub 0 in, we get 3x squared, and then both of these pieces here are going to become 0 because we have 3x times 0 and then 0 squared, so we just end up with a final piece there, which is 3x squared, which is exactly what we were looking for. So there we go, there's another one. Now our last one that we're going to have a look at is going to involve a bit of fractions. It's definitely our hardest one out of the bunch, but let's have a look at our final question here to finish this off. Okay, so for our final question here, we've got to show, obviously, that 1 over x is going to equal minus 1 over x squared. So our function of x this time is 1 over x, and we're trying to get it to make minus 1 over x squared. So let's have a look. Now, obviously, we'll write down our little formula again. So f of x plus h minus f of x all over h. So again, if you want to have a go at this one, it's a little bit more of a tricky one, but pause the video there and have a go, otherwise we're going to go through it. So let's just sub these pieces in. So we'll put x plus h in place of x, so we have 1 over x plus h, take away the function of x, which is 1 over x, and that's all over h. Now again, you can see why this isn't very nice, because obviously we've got a fraction on top of a fraction. But in terms of obviously those fractions on the top there, we just need to actually sort those out and combine them together. So we can do that by making a common denominator. So if we multiply this right fraction by that left denominator, which is x plus h, and we multiply this left fraction here by the right denominator, which is x. And there we go, obviously we're going to multiply that on the top and the bottom. So if we multiply the top of the left fraction there by x, we get x over, and if we multiply the denominator there, we get x squared plus xh or hx. There we go. Doing the same to the one on the right, multiply the numerator by x plus h, we get x plus h, and the denominator there, we get the x squared plus xh. So there we go, there's our numerator. It's all over h. Now obviously let's tidy this up first and then we'll worry about that h on the bottom. But if we tidy this up, we've got x on the top there, take away another x, so that leaves us with nothing, and then we've got nothing take away the h here, so we're going to have minus h on the top. So we've got minus h on the top, and that's over x squared plus xh. Now in terms of obviously that divided by h on the bottom, and let's just highlight that because we're still going to incorporate that, rather than writing it as a double fraction, I'm going to write divided by h, and instead of writing it as h, I'm going to write it as h over 1. So there we go. So obviously we can apply our normal fraction rules for division here. We can just obviously multiply it by the reciprocal, so we can times by 1 over h. So if I bring this up here, let's have a look. We've got minus h over x squared plus xh multiplied by 1 over h. And if we multiply these fractions together, 1 times minus h on the top is going to leave us with minus h. Let's just write this out. So we have minus h on the top, and on the bottom there, we're going to have x squared h, timesing both these pieces by the h, plus xh squared. Okay, there we go. So there is our fraction at the moment. What we can do now is just like we've done before, we can divide the top and bottom by h. I'm going to write that in next to this. So divide the top and bottom by h. And if we do that and we divide the top and bottom by h, on the top there, we're going to get minus 1. Minus h divided by h is minus 1. And on the bottom, we're going to get x squared plus xh. There we go. So minus 1 over x squared plus xh. Now again, obviously we can't simplify this any further. So if we have a look at where our limit of h approaches 0, and let's see what we get. Well, if we do that, we get minus 1. And let's just write this out. We get minus 1 on the top over x squared plus 0. Okay, there we go. So we've got nothing left on the bottom. I actually left a little bit of space there just in case we had something, but let's just change that into x squared. There we go, so minus 1 over x squared. And actually, that is actually the same as just dropping that negative on the outside of the fraction. So that will become minus 1 over x squared, and there we go, that's what we were looking for. So there we go, there is our final question. Obviously that was quite a tricky one there because in the earlier steps we had some algebraic fractions to deal with as well, but there are 5 questions for you on proving from first principles some of these different derivatives here. So there we go, hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.